Welcome one and all. This is a continuation to our previous video list on how to implement linked list using C language. Now, in this particular video, we are going to see how to implement stack using linked list. My name is Vikas Bandaro. I'm working in Vidyajyoti Institute of Technology under Computer Science Department. So, first of all, let us try to understand what is a stack. Stack is the data structure which follows LIFO order. So what is LIFO? It means there will be only one entry, and that entry will also act as exit. So only one entry or one exit. And so we can only insert or delete elements from one end. Let us see a small diagrammatic view. As you can see here, if we consider this box as stack, then the elements are inserted in a LIFO order. As you can see, the first element which is inserted goes to the bottom, then the second one is the second bottom, and the last one that is inserted is at the top. And when we are deleting elements from the stack, the last element which was inserted goes to the top, goes out first, and then the next, and then as you can see, the last element that is inserted goes out last. Let us see some examples, some real-world examples. This is a books stack, and if I want to take out the last one, I cannot take out the last one directly because all of the books will form down. I can only take out this last book that is inserted, and I can only access the last book for the first time, and then the next one, and this and so on. Let us take another example. This is, as you can see, an idly rack. Again, this also follows the same rule. It is a LIFO structure. Whichever rack is inserted at last can only come out first. Another example, a coin stack. Another example, a chair stack. And then playing cards stack to make a pyramid with it. And then, as you can see, it is a factory resource center where all those containers are saved as in the form of a stack where only the last element can be taken out first. So what kind of operations we have in stack? The main operations of stack are called push and pop. Push is nothing but a different way of telling insertion. Push is just a stack terminology for saying that this is insertion, and pop is the stack terminology for deletion. So when we are trying to push an element, as you can see, these are all different elements, and by element I mean this box which internally contains the data. Data here could be the value, like as you can see, this particular box, an element contains 31 as the data. This box, an element contains B, a character B as data, and then we have integer 12 as data in another element, integer 3 as data in another element, character A as data in another element. So as the way the elements are pushed into the stack, the first element that was pushed goes to the bottom, and so on and on, and this is the last element that is going to be pushed into the stack. And if suppose this is pushed into the stack, then that could be the only element that can come out first. So when we pop, the topmost element of the stack goes out first. So these are the two main operations of stack. And LIFO means last in, first out. So the last one gets in only gets out first. So let us try to compare stack operations with linked list operations that we have already seen before. What kind of linked list operations do we have? First of all, especially in a singly linked list, if we consider this is our singly linked list where this is a single element and this is the data of the element, as you can see, this element contains two parts. One stores the data of the element and another stores a link which will be pointing to another element of the similar kind. And here in this particular list we have three elements. All of them are having the same data type, especially integer type values, and every second part of the element is a link which is pointing to the similar type or to null. And we have a pointer which is pointing to the first element of the list, as you can see, and we are calling this particular pointer as head or start, which is representing that this is where you can start traversing your linked list. The operations that are available in singly linked list are insertion and deletion at beginning, insertion and deletion at end, and insertion and deletion at a particular position.